Hey there, and welcome. Today, we are going to pull back the curtain on exponents. You know, if you've ever seen that little number kind of floating next to a bigger one and thought, what's that all about? Well, you are in exactly the right place. We're going to make this whole thing super simple.
So just imagine for a second you had to write this out. It's a lot, right? It's long, it's super repetitive, and let's be honest, it's so easy to lose count. Now, if there's one thing mathematicians really aren't fans of, it's doing the same boring thing over and over. So they came up with a way better solution. And that solution is exactly why we're here.
And that solution is, you guessed it, the exponent. You should really just think of it as a powerful shorthand. It's a shortcut for all that repeated multiplication. It's basically a way to clean up the mess and write these huge numbers in a tiny, neat little package. So what is an exponent, really? Well, it's just a little piece of math notation that tells you exactly how many times to multiply a number by itself. I kind of like to think of it as a command, you know? It points at a number and says, hey, you, multiply yourself this many times. It's super efficient. Okay, to really get this, we've got to break it down into its parts. It's time to pop the hood and see what actually makes an exponential expression tick.
So let's use this as our main example for today. You'd read this out loud as 2 to the power of 8. And yep, this is the simple answer to that crazy long multiplication problem we saw a minute ago. Now, let's zoom in on the two numbers here, the big 2 and the little 8.
First up, we've got the base. In our example, that's the number 2. The base is always the big number on the bottom. Think of it like the main ingredient in a recipe. It's the thing that's actually getting repeated. So, the key takeaway here is the base is the number you multiply.
And that little floating number, well, that's the exponent. Sometimes people call it the power or the index, too. Here, it's the 8. The exponent is basically the instruction manual. It tells the base, all right, buddy, you need to multiply yourself 8 times. It's the boss of the whole operation.
So when you put the base and the exponent together, just like this, you get what we call the exponential form. It's this super compact, really tidy way to represent what could be a massive number. Now, here's where it gets really interesting. This exponential form, it isn't the only way to talk about this number. In fact, there are 3 totally different ways to write the exact same value. And this table just lays it out perfectly. Look, over on the left, that's our exponential form, 2 to the 8th power. Right in the middle, that's the standard form. That's the actual number you get when you do all the math, 256. And then all the way on the right, that's the expanded form. That's the long, messy version we started with. See? 3 different outfits for the exact same number.
Okay, so positive exponents. Pretty straightforward, right? But what about negative ones? This is where a lot of people get tripped up. But I promise you, there is a super simple rule for this. The key is, don't panic. Just think, flip it.
This is the big question, isn't it? A negative sign in math almost always means, less than 0. But with exponents, it means something totally different. It has nothing to do with making the number negative. It's all about changing its location. So here it is. Here's the secret rule. A positive exponent, like a to the power of m, is just business as usual. Multiply, multiply, multiply. But a negative exponent, a to the power of negative m, well, that just means you take the reciprocal. You flip it. You turn it into a fraction, 1 over a to the power of m. That's literally the whole trick. That little negative sign is just an instruction that says, hey, flip the base. Let's see how this works with a real example. Say you've got 12 to the power of negative 7. You're not going to calculate some negative number. Nope. You just use the flip it rule. It instantly becomes 1 divided by 12 to the power of positive 7. See that? The negative sign's job is done as soon as you do the flip. Now, of course, there's a fancy-pants mathematical name for this relationship. It's called a multiplicative inverse. But don't let the term scare you. All it means is that one is the flipped version of the other. So a to the negative m is just the multiplicative inverse of a to the positive m. It's our simple little idea, just wearing a tuxedo.
All right, we have covered a lot of ground pretty quickly here. So let's wrap this all up by boiling it down to the absolute core ideas, the key things you need to walk away with.
So, let's recap. Number 1, exponents are just a shortcut, a shorthand for multiplying a number by itself over and over again. Every time you'll have 2 parts. The base, that's the number you're multiplying, and the exponent, that's the little number telling you how many times to do it. And number 2, if you ever see a negative exponent, do not freak out. It's just a signal telling you to take the reciprocal, Or, as we've been saying, just flip the base into a fraction.
And I'll leave you with this final thought. Exponents are not just stuck in a math textbook. They're out in the real world, describing things that grow and change incredibly fast. I mean, think about how a video goes viral. If one person shares it with just 2 friends, and they each share it with 2 friends, you go from 1 viewer to 2 to 4 to 8 to 16, and before you know it, you're at millions. That's exponential growth. So the real question is, now that you speak the language, where else do you see it happening all around you?